This is a lesson on density. Density is a measure of how packed the matter is of an object. If you have a lot of matter in a very small space, that would be dense. If you have very little matter in a larger volume, that would be less dense. So matter is, density is mass per unit volume. In chemistry, since we work with smaller amounts, that would be grams per cubic centimeter. And remember that 1 milliliter is 1 cubic centimeter, so those are the same things. And for the equation that we use, density is mass divided by volume. So you'll have two of those unknowns, and you'll try to find another one. For example, if your mass is 20 grams and your volume is 5 cubic centimeters, what is the density? 20 divided by 5 is 4 grams per cubic centimeter. Remember your labels. Another example would be if you have a density that is 15 grams per cubic centimeter and a volume that is 10 cubic centimeters, then what you do is you plug it into the equation. The density you know is 15. Up here the density is 10. Okay, up here you know the density is 15. The mass you do not know, so that's your M, and your volume is 10. So you multiply both sides by 10, and you get 150 grams, because that's your mass. The last sort of math problem, density is equal to 3 grams per cubic centimeter, and your mass would be 18 grams. What is the volume? Plug in what you know. The density is 3. The mass is 18. You're trying to find the volume. Now, a neat trick here is if you cross multiply, 3 times b is the same thing as b times 3. So you can switch that and put b equals 18 over 3. It makes the math a little bit easier to do. 18 divided by 3 is 6 cubic centimeters, which is the unit of volume. Density graphs. If you graph the density and you put the mass on the y-axis, grams, mass in grams on the y-axis. On the x-axis, you put the volume of the object, and that is in cubic centimeters. And if you were to plot that information and you draw a best fit line, or a close best fit line, it'll look better. What you would do is to find the density, find the slope. The slope is change in y over change in x, and y, change in y would be in grams, because that's in the y-axis. Change in x is cubic centimeters, so that's the density. So the slope of that would be the average density for for your lab data that you gather. So the average density is equal to the slope of a mass volume chart. Floating in layers. Sometimes the reason something will float is that it is less dense than the surrounding material. Material. So if you have a hot air balloon, floats because hot air is less dense than the cold air. Helium balloons float, same reason. Wood would float, but a block of iron would not float because its density is less than water. The density of water is unique. It's 1 gram per cubic centimeter. Again, hooray for the metric system. So if you have any number greater than 1, it's going to sink in water. So if the density is greater than 1, it's going to sink in water. And if the density is less than 1, it will float. Ice floats because the density of ice is approximately 9 grams per cubic centimeter. And that's fortunate because that way the oceans won't freeze over. Ships, even though they're made out of iron or aluminum or some piece of metal, the reason they would float is because of the hull. The average density of the entire ship is less than 1 because of the space occupied by the hull. And then that would do that. Layering, like in smog and stuff, Las Vegas or Los Angeles, what happens is they're in a low spot, they're surrounded by mountains and the ocean, and the smog collects in a layer because the smog has chemicals more dense than air, regular air, and it collects in the valleys, and that's why smog occurs. Sometimes fog occurs in the lowlands, same reason. The water vapor is heavier and it'll go towards the bottom. And that ends this lesson on density.